we want to look at various hyperbolic functions. The first one is the hyperbolic sine. Now, that is usually written as sine and h, but generally it's pronounced shine, right? So you generally pronounce it. Now, these hyperbolic functions, such as shine, they are expressed using what the number that's called the Euler, the base of natural logarithms. All right. So, for example, sine h of x is equal to e to the power of x minus e to the power of negative x divided by 2. Right? Now, let's test this thing out a bit. Let's use want to draw for our calculator here. Calculator, let's use this calculator. Know that this calculator can be put in radian mode. So we have radian mode here, because when we calculate the sine, cosine, and tangent, or the hyperbolic sine, we're talking about using radians. All right. So let's just quickly be reminded here what we're dealing with. We'll talk about radian mode. Let's say this is in degree mode. This ends at 360. This is sine x, not shine for now. Just a quick reminder, 180 degrees. Now, this 360 degrees would be 2 pi radian, and this 180 degrees would be pi radian. Remember, 1 radian is the angle formed, the angle theta, when the length of the arc here along the circumference is equal to the radius. All right? Now, if you want to cover 1 full circumference, the thing is, how many arc lengths of this would you have to cover? How many radians or radius? Well, the circumference is 2 pi times the radius. And if you say this is the radius and you call it 1 radian, it is 1 radian. So 1 circumference covers 360 degrees, which is 2 pi radians. All right. So just a quick reminder. And if you half both sides, you see 180 degrees is equal to pi radians. All right. So we have our calculator in radian mode. Now 2 pi is the same as 2 times 3.142, which is what, 6.284 or something like that. So let us say x is equal to any number. Well, like what? 1.5. Now, the shine of 1.5 is equal to e to the 1.5 minus e to the negative 1.5 over 2. Now remember, e to 2 decimal places would be 2.718 to 3 decimal places, or 2.718. So let's do a little thing here. 2.718 to the power of 1.5 minus 2.718 to the power of negative 1.5 over 2. This will be the same thing as 2.718 to the 1.5 over 2 minus 2.718 to the negative 1.5 over 2. But at this part, when you say to the negative 1.5 over 2, the over 2 would be half times 1 over 2.718 to the positive 1.5, right? So let's work these out with our calculator. Let's get back to our calculator here. Let's use this. Okay, so 2.718 to the power of 1.5. 2.718 to the power of 1.5 equal that. Divide that by 2. That over 2 equal. You have 2.24. Alright, 2.240. So you have 2.240 minus. Then we're going to do this calculation. Let's get back our calculator. So now we have 2.718 to the power of 1.5 equal. And we say 1 over that equal, or 1 divided by, so let's do it that way. So we have 1 over open bracket. Now let's clear it first. All clear. Okay. 1 over open bracket 2.718 to the power of 1.5 close bracket equal. Alright, so that's what we have. And then this now over 2 equal 0.111, call it 0.112, 0.112. Alright, so we use this. We're going to see what that amounts to. So 2.24 minus 0.112 equals 2.128. So 2.128. Now, let us just find the hyperbolic sine of 1.5 and see what we get. So here, let's put this in radians. Oh, all clear. Radians. 1.5 hyperbolic sine. 2.129, kind of close. It's because of the rounding off, you don't get the exact thing. So you have 2.129 compared to 2.128. To two decimal places, it would be 2.13. Alright? So that would work with any number. So that shows you an example where the hyperbolic sine or sine 1.5 equals e to the 1.5 minus e to the negative 1.5 over 2. So here, what you have is e to the x minus e to the negative x over 2. That's an easy way to remember it. You can write it in another form, e to the x over 2 minus 1 over 2 e to the x. Same thing, alright? But it's usually written in this form. So, this is sine x. We'll look at cos x in our next video.